Yeah. Hello, everyone. Thanks for joining the call. And I'm Yingjun, and I'm the founder of RisingWave Labs. Today, I'll be talking about the RisingWave roadmap in 2024. So in this talk, basically there are two things I want to cover in this talk. Okay, so first one, I want to introduce what we have already done over the last 1 year. And then the next thing is that what we will do in the following year. So about RisingWave, if you're not familiar with RisingWave, and probably if you do not really have any idea about, okay, what is streaming database. So one quick sentence about what RisingWave is. RisingWave is a Postgres for stream processing, analytics, and management. So it's a Postgres compatible database, a distributed database that speaks in Postgres SQL dialect. And it's optimized for stream processing, and it can do analytics, and also it can persist your data and manage your data in the cloud. So there are two features highlighted in RisingWave. One is ease of use, and the second one is cost efficient. So we started building RisingWave in early 2021, and we have already entered actually the fourth year, right? We have already spent 3 years developing systems. And in April 2022, we open sourced the RisingWave on GitHub under Apache 2.0 license. And we released the RisingWave 1.0 in July 2023. So we have already had hundreds of customers and users using RisingWave to do stream processing, management, and analytics across the world. And this map shows the distribution of our users. So RisingWave, one of the highlights in RisingWave is that it's so easy to use. It's compatible with Postgres, and you can just use RisingWave like the way you use Postgres. And it fully supports a Postgres ecosystem. So think about probably you're familiar with some BI tools like Superset, Grafana, Metabase, right? Well, all these systems are compatible with Postgres, and you can directly interact RisingWave using these BI tools. Similarly, you can use dbt, and you can also use all kinds of the language drivers, such as Python, Go, JDBC, Node.js, and others. So RisingWave's another key feature in RisingWave is that it simplifies the architecture significantly. So it's a streaming database, so it can do stream processing. Plus, it's a database that can persist your data. So if you use RisingWave, if you do not really use RisingWave, then I think for many people, the streaming database architecture or the streaming data stack looks like stream processor plus a messaging queue, and then plus a stream processor, and then plus a messaging queue, and then plus a database to store the data. So that if you want to query the results, you have to fetch the data in the database, right? But in RisingWave, it's a totally different thing, because you can just create materialized views to represent your stream processing logic. And the materialized view is directly queryable by through your, let's say, BI tools, or just use a JDBC driver or use any other language drivers you like. So the key architecture of RisingWave is still totally different from conventional stream processors like Flink, like Spark Streaming, and probably Storm and Samza. So if you are a Flink user, probably you are familiar with how data architecture looks like. It basically used the heap-like architecture or MapReduce-like architecture, which means that we partition the data into different pieces and then shift the states into every single machine, so that every single machine only need to take care of its own data. But in RisingWave, we adopt the snowflake style architecture, which means that you can use the S3 as the primary storage. The internal states will be directly persisted in S3, so that you can scale in and scale out the architecture, the computation layer as you want, as the workload grows. So because of the architecture, RisingWave can recover from failures in seconds. If you have one machine fail, then you can just reload. In RisingWave, you do not need to wait for, let's say, 10 minutes or probably 30 minutes or probably 1 hour. You can just reload the states from the remote machines, or you can just boot a new machine, and a new machine can directly access the states in the remote machine, in the object store, remote object store. And similarly, in dynamic scaling, I think this is one of the favorite features that our users really love. That is where they can actually scale in and scale out in seconds. Well, because all the states are stored in object store. So if you want to scale from one machine to 3 machines, what you only need to do is that create the 3 machines and ask these 3 machines to fetch the data from the remote storage instead of doing complicated state migration. You do not need to stop all the machines and stop so-called stop reward and then do scaling, right? Well, you do not need to do that. So in terms of performance, well, RisingWave is much more performance than the other streaming processors. First thing that if you want to do a streaming join, then one of the key things is that you probably have to worry about, well, if you're using, let's say, Flink storms or some others systems, you probably need to worry about the state size, right? Because for streaming joins, it typically comes with large states. But in RisingWave, it's like, okay, all the states are persisting in the remote machine. So, the remote object store, you do not need to worry about the state size. The other thing that RisingWave can do is that is optimizer. The database optimizer is specially designed for stream processing so that it can actually identify what kind of query plans should be used to process such kind of stream processing joins. And we have really achieved a stable and efficient performance in several use cases, or in several production use cases. They can achieve, let's say, dozens of over actually 20 event joins. So in terms of the ecosystem, we will continue to grow our ecosystem. If you look at this picture, we actually already have support for all kinds of database systems and actually data systems. For example, for the upstream systems, we have the support for message queues like Kafka, Repana, like whatever, right, or Ponza, right? And we can also do, let's say, database CDC, like we can do Postgres CDC, we can do MySQL CDC, and all kinds of the CDCs. And definitely, you can also fetch the data directly from the object store, right? Because probably a lot of people's historical data are stored in S3. In terms of downstream systems, we definitely support a lot of OLAP databases like ClickHouse, like Redshift, like Snowflake, right? And the data lakes like Iceberg, Hudi, and Data Lake, right? And also definitely messaging queues and operational databases like MongoDB and Kafka. So a lot of people ask me about, okay, how RisingWave is different from the Flink. Well, I think the answer here is that, it's 2 different systems, and it's just a thing about how Spark is different from Snowflake, right? Spark is a data engine, and it's optimized for batch processing. And Snowflake is a database or data warehouse, right? Well, it's a data system, and it's a SQL-based data system, and it can do batch processing, but you do not need to, and it also store data. You do not need to worry about, okay, where I should store data, right? And similarly, in the streaming domain, Flink and RisingWave are 2 different systems. Flink is a streaming engine, while RisingWave is a database. And RisingWave speaks SQL, but Flink speaks probably Java and some other languages. And Flink doesn't really have storage, but RisingWave do have the storage, right? It can do stream processing and streaming management and streaming analytics. So in terms of functionality, both RisingWave and Flink support all kinds of the advanced stream processing features, like exactly one semantics, like watermark, like time wandering, like database CDC, and many others. But the different thing here that Flink has is Java API and Python API. Well, RisingWave doesn't really have that. What RisingWave has is the Java and Python UDF. If you use Snowflake or if you use RisingWave, then if you use Snowflake or probably if you use Redshift, you will know that okay, all the databases have such kind of Java UDF and Python UDF, right? RisingWave allows people to define their streaming queries in Java and in Python using the UDF functionality. And then another big difference between RisingWave and Flink is that RisingWave is a database and it's fully Postgres compatible. Think about if you have all kinds of, let's say, database management tools like dbeaver, right, where you can directly connect it RisingWave with a dbeaver. And it can also do query serving, meaning that, if you want to directly serve the queries, you probably do not serve the results. You definitely do not need to have a separate data system or probably keyword stores or whatever to serve a query, because RisingWave has already had its own storage, and that's definitely the main difference. And some other thing here that Flink is emphasized on comprehensive functionalities. Well, as I just mentioned, bro, it has a SQL API, table API, and it has the Python API and Java API. But so that you can probably write your Java code, or probably you can write your Python code, right? But RisingWave is totally the emphasis is totally in different things. Well, it's emphasizing ease of use and cost efficiency. We always tell our customers that you can actually cut your bill to half, more than just half, 50%, probably cut from 200 calls to only less than 100 calls, so that you can save a lot of money and you can focus on develop the stream processing engine, stream processing applications. And you do not need to, and it's just about the performance, right? Well, but if you think about the whole picture, if you think about the architecture, if you use Flink, you probably need to have Flink plus Kafka plus database. You have so many systems, you have to manage all these kind of systems, and you have to pay the bill for all these kind of things, right? But in RisingWave, it's totally different. You only need to take care about your materialized views, right? Actually, everything is in one single system. So I will spend 5 minutes to talk about RisingWave's best use cases. Definitely, the first thing is streaming joins and real-time ETL. A lot of people use RisingWave to do the ETL because, they probably want to have flatten data, right? So they probably want to do the multi-stream join from your optional databases or from messaging queues and join all these, do all kinds of transformations, and then deliver the results into your favorite data lakes or probably the data warehouses, right? So in RisingWave, I don't know how you will do that in some other systems, but in RisingWave, there's just 2 lines of code. For example, if you want to do some real-time ETL from Postgres to Iceberg, there are only 2 lines of code. The first line is that create songs my PG, and to tell the RisingWave, okay, where your PG is, right? And to send data from RisingWave to Iceberg, you only need to create another state that will create sync my Iceberg to tell people, okay, where you want to send the data to. And then you can also need to, definitely you need to define your query, like as select something from my PG where the statement, right? That's a thing. And about, the streaming join, if you want to do, let's say, that's probably a simple example, but if you want to do streaming joins, let's say join the data stream from MySQL and join another stream from Kafka, then it's just three statements, right? So the first statement is that create the source, right? And the second statement, create source and tell people that you are doing you are connecting to the Postgres CDC. And the second statement is that you tell people that you create your database to RisingWave to Kafka and tell people where the Kafka is, right? To tell RisingWave where the Kafka is. And to join these 2 streams, you only need to create a third statement called create my Iceberg, and tell the RisingWave how to handle your stream processing logic. Okay, so another simple example about use case is to help people to simplify their streaming data architecture. So this is a pretty standard streaming data stack in a lot of companies. they use, as I just mentioned, the Flink plus Kafka plus Flink and plus some other systems to do the stream processing. But in RisingWave, the thing here that you can just use one single system and do all the stream processing logic. You don't need to have a messaging queue. And what the code will be look like. Let's say that you can just create a source and then define your let's say the stream processing logic using the language like create materialize view as, and then create a sink. Tell RisingWave where you want to send your data to, probably to Iceberg. Then you can just use the statement like with connector equal to Iceberg to send the data to Iceberg. And more than that, RisingWave can replace your, the keyword stores and the Postgres, because it only has its own storage, so that you do not need to store your result in a separate system. So that's about the serving runtime dashboard thing. So, okay, that's the RisingWave, what we have done over the last 1 year. And let's talk about, RisingWave's roadmap in 2024. The key thing we will announce is that, in this first half is that we will expect to release RisingWave 2.0 in Q2 2024. So we will be focused on a key concept called unified stream and batch processing. So it has two parts. One is batch ingestion, and the second one is batch processing. Now we talk about the unique value prop later on. So let's talk about the status, current status of RisingWave. A lot of people can think that RisingWave right now cannot ingest the batch data from external systems. For example, a lot of people probably have the CSV files in their let's say S3, right? In RisingWave, you can definitely do streaming reads from your S3, but the problem here is that if I have a large amount of data stored in S3, and I just want to batch load from S3 to RisingWave, I probably cannot do that. Then what do we do that? So that's definitely a problem, and we are currently working on that. And I believe that pretty soon that we will have an answer. And the second frequently requested feature is that RisingWave right now doesn't really have the column storage and the inverted index, which means that if people really want to analyze the data efficiently in RisingWave, let's say do a large table scan, then they probably have to scan. Then they probably need to sync the data onto a certain, the OLAP databases or probably Elasticsearch, right? That can complicate the architecture. That's probably not what we want. So in 2024, we were, the first half in 2024, we will definitely focus a lot on unified streaming and batch processing. There are two concepts we want to focus. The first one is that we want to focus on, allow the user to ingest and analyze both the streaming and the batch data. That's number one. And number two is that we will allow the users to manage and analyze persistent data. So let's talk about the use cases of batch ingestion. Users may want to import historical data from the data lake and read real-time data from Kafka. Right? Let's say that we have historical data from S3, and I have a real-time data in Kafka. Right? Probably I want to import both the historical data and the real-time data. That's definitely a solid use case for batch ingestion, right? And the second use case is that users may want to join an event stream from Kafka with another data stream from with another dimension table, let's say stored in Postgres. What we can do? We need to do streaming joins. Your table is stored in Postgres, probably stored in data lake. Then how we join that? That's a problem, and that's actually also motivated us to develop also called the functionality called batch ingestion. So within the next couple of weeks, we are currently working on the batch ingestion. We will support batch ingestion from various systems like databases, data lakes, and other systems. The ingested data will be just stored as a table in RisingWave so that you can do efficient analytics, performance, and probably joins inside of RisingWave. and you do not need to use another third-party system to think about. I'll probably use the UDF to allow RisingWave to fetch the data from external systems. Note that, please note that the imported tables will be considered as a snapshot of the data, so that you do not the data will be static. And definitely you can just append more data into the table, but for the data you loaded into the database is static. It's a snapshot of the external table. From the user experience, well, users can only you only need to use the statement called will create some table. We'll think about the name, create some table to batch ingest the data from the external table from external systems. And then let's talk about the batch processing. The use cases here is that users may want to perform analytics on data stored internally in RisingWave. So many people may know that RisingWave actually have a row store, and the row store is probably not that efficient for handling the long-term scans, right? Long-range scans, right? It's not efficient at all. So what we will do is that RisingWave will introduce a new storage format for the base table, and it will have both the column storage and inverted indexes. And the user's experience will be like user can just choose the storage format when creating base tables. For example, you can just use, like, say, if you are familiar with, let's say, MySQL, you probably will know this statement called create a table something with engine equal to something, right? And in RisingWave, you will do the same thing. You will be allowed to do the same thing to choose your own engine, to choose your own data format. You can use just store it in column store, or probably store in inverted index, or probably just store in row store. Totally depends on your own use cases. And that's for the batch processing. And actually, what I just talked about is that people probably want to analyze the data stored in RisingWave. And the RisingWave's materialized view also holds the stream processing results. So users may also want to further analyze the results stored in RisingWave's materialized view, right? And what they do right now, they probably think that, okay, probably I want to use Elasticsearch, because for Elasticsearch have an inverted index, so that I can do full text scan. Full text search, right? Yeah, but well, I mean, you can definitely introduce Elasticsearch, but well, the thing here that Elasticsearch is pretty heavy, and you have to figure out, okay, how I tune the performance and how I can operate Elasticsearch, right? That's a big problem. So our solution here that we will allow people to introduce new data formats for materialized use. So basically, it's still same thing. I mean, we will introduce a column storage and inverted indexes. So from the user's experience, they can essentially create index on top of materialized views, and you can choose the index. Look, with the column storage and the converted index can be considered as a new type of index, right? You can just create an index on top of your own existing materialized views, so that you can do fast analytics directly over the newly built indexes. That's the solution we are currently working on. So yeah, that's about the batch processing part. So what you can see here that look, RisingWave will be able to do batch processing, and will be able to do streaming processing, and definitely will also do the storage, right? But the problem here that what's the unique value prop of RisingWave, right? RisingWave, there are a lot of systems that can do batch processing, and there are a lot of systems can do stream processing. So where the RisingWave's unique value prop, or where the RisingWave sits in your own unique in your own data stack. Well, our proposal here that RisingWave 2.0 will be your only real-time system you need to handle your real-time data. You can do processing, analytics, and management. So if you don't really understand about what that, you think about, okay, if you want to use what do we do if you use, let's say, a stream processor such as Storm, or probably SAMS, or probably Flink, or probably Spark Streaming. You can use these kind of streaming processors to do stream processing. but you still need to have a database to manage the stream results, right? Stream processing results. And you probably cannot do, query serving because, Flink doesn't really have the storage. Spark streaming doesn't really have the storage. You have no way to do the storage. You probably have to introduce another system to do all kinds of the, let's say, the query serving analytics, right? But RisingWave is a streaming database, so it's the only system you need. You don't need to separate stream processor. You don't need to have a messenger queue. You just need RisingWave to handle all your real-time requirements like real-time data processing, analytics, and management. But one thing I want to clarify here is that RisingWave will not replace your Snowflake. Because, Snowflake is for historical data. Probably you have a large amount of data stored in as a Snowflake. But right now, RisingWave is not suitable for handling large amounts. Historical data processing. Because for that, if we want to do that, we probably need to focus a lot about how we want to optimize, let's say, the query engine, definitely query engine, and also how to optimize the storage, right? There are a lot of things to do, and we are not trying to replace your data warehouse. But definitely, if you think about, I just want to store data as a stream, as how it comes in, for sure, RisingWave is a right to-go solution for that kind of use cases. All right, and that's what I have today. And if you are interested in RisingWave, and if you want to learn more about the stream processing and how RisingWave can serve your stream processing applications, then just join our Slack community, risingwave.com/Slack. That's it. All right, I'm Yingjun Wu. Thanks for having me here, and have a good rest of the day. Thanks.